Hey, mathematicians, we're going to be starting Unit 13 today. And so this unit is going to be just a short unit. We've got 3 sections and then our quiz on Friday. So it's meant to be super short. We're just going to be touching on radicals today. So what's a radical? Okay, well, a radical is a number that has a square root symbol. Okay, so basically saying that. And so just kind of going back a little bit about what we've talked about earlier in the year versus rational versus irrational. Rational numbers are numbers that can be written as a fraction. The decimal either ends, it repeats. Irrational numbers are numbers that can't be written as a fraction, or the decimal never ends or never repeats. Okay, the most common irrational number is pi, or, and this is where the radical piece comes in, the square root of any number that is not a perfect square, right? So rational versus irrational. It was a while ago when we chatted about that, like probably September, but just kind of giving us some background. So we're going to be talking about that in terms of rational numbers will be the square roots of perfect squares, and then irrational will be the numbers that are the square root of non-perfect squares. So that might beg the question, what is a perfect square? Well, when we look at what perfect squares are, they are numbers that their square root is a rational number. So the highlighted numbers on this screen are perfect squares because the square root is a rational number. All right. And you'll be referring back to this screen or this piece, as we go through that. But if you're, working on your quiz and you're like, gosh, what are the perfect squares? What you can do is just say, okay, 1 times 1 is 1. So 1's a perfect square. 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9's a perfect square. So that's a strategy you can use to find the perfect squares if you're not quite remembering what they are. Okay, so here's a list of them. All right, so here's our first task. Between which two consecutive means in a row, integers are numbers with no decimal, no fraction. So between what two numbers with no fraction, no decimal in a row does this radical fall between? Okay, so if I've got the square root of 17, all right, the square root of 17 is going to fall in between 4 and, whoops, I'm sorry, I said that wrong. It's going to be, 4 and the next one would be 5. Now, how did I get that? So the square root of 17 is between these two perfect squares. So let me erase this maybe and go the square root. It's between the square root of 16 and the square root of 25. It's between these two perfect squares. So 17 is between 16 and 25. The square root of 16 is 4. The square root of 25 is 5. So those are the two consecutive integers. Okay, let's look at 86. So 86 is going to fall between 81 and 100. So the square root of 86 is going to fall between the square root of 81 and the square root of 100. The square root of 81 is 9. The square root of 100 is 10. So the two consecutive integers that it falls between are 9 and 10. All right, this next one is taking a little bit of a twist, and it says approximate to the nearest whole number, the nearest integer that goes to. So the square root of 30 is between the square root of 25 and the square root of 36. So the square root of 25 and the square root of 36. 30 is closer to 25, so the square root of 30 is closer to the square root of 25, which is 5. So 5 is the nearest whole number. For 70, that's going to fall between these two numbers. It's going to fall between the square root of 64 and the square root of 81. 70 is closer to 64. Therefore, the square root of 70 is going to be closer to 8. Right? So utilizing this, feel free to write that on your worksheet. Feel free to have that written out somewhere. This is going to be helpful to have those perfect squares written out. And again, if you forget, gosh, how do I remember those? In your mind, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And work through those to get all the way up as far as you need to go. All right, so square roots. All right, radical symbol, square roots. Something I want to point out is how you write your answers. If there's no sign in front, we will put no sign in front of our answer. If there's a negative sign in front, we put a negative sign on the answer. And this symbol is called the plus negative symbol. It means we want both the positive and the negative. So we will list both the positive and the negative. Another way that you could write it would be positive, negative 4. That's another way to write that out. And it doesn't matter which way you do it. Okay. So the square root undoes a squared quantity. Okay. So when we have an equation like this does, when you square root it, we're going to give both answers. Okay, come on, Ms. Shopper. You just said if there's a sign in front of it, we put a sign after it with the answer. But if there's no sign in front, we're not supposed to. And you're probably thinking, there's no sign in front. How do I know that? The difference is these 3 are expressions. This is an equation. And when you solve the equation, you want all the possible answers. Okay, so this is the note. If you write the absolute value symbol in yourself, you must include both answers. Okay, all right, so let's try to figure out what these square roots are. All right, so we've got the square root of 81. There is no sign in front, so we'll have no sign in the back, so it's going to be 9. All right, when we look at the next one, there is a sign in front, so we're going to make sure we have that negative sign. The square root of 64 is 8. Okay, so if you've been tuning out a little bit, I need you to tune back in to hear this. Okay, this next example, the square root of negative 9. Notice how the negative sign is inside the radical. All right, so if you have the negative sign inside the radical, it's actually going to be an imaginary number. Now, in 8th grade, we don't talk about imaginary numbers yet. All right, that's something you're going to be talking about when you get into Algebra 2, is imaginary numbers. So for our purposes, you're going to put no real solution. All right. Now, for curious minds, like, I wonder what it's going to be like in Algebra 2, the correct answer is actually 3i. Okay, but for our purposes, you can just put no real solution because we're only talking about real numbers. And with this last one, we have a plus negative. It's going to be positive negative 5. All right, just a little bit left, and we're going to give you some work time, okay? So evaluating expressions with square roots. So what have we done before? We've given you expressions. We've given you values for numbers, and we've asked you to plug them in and evaluate. We're doing the same thing here, all right? So we have the square root of b squared minus 4ac. So I substitute in all of my numbers, and now I'm going to evaluate it through. So the square root of 8 times 8 is 64. 4 times 7 times 1 is 28. All right? I'm working on evaluating. Same process that I've been working on throughout the year. All right, so now we've got the square root of 64 minus 28 is going to be the square root of 36. So the answer is going to be positive or negative 6. Okay, positive or negative 6. I put the square root symbol in there. We're going to go with that. Let's try one more. The square root of b squared, so it's going to be negative 10 squared minus 4ac, right? So the square root of negative 10 times negative 10 is positive 100. 4 times 1 times 9 is 36. So the square root of 64 is positive or negative 8. All right. Evaluating, continuing to build on skills that we've been talking about already. All right, here we go. Continuing to evaluate, same skills. Now, look, we have this plus minus here. That means we're going to have 2 answers. We're going to have one where we add them and one where we subtract. So 3 plus 4, the square root of 25 is 5, divided by 2. We're using our order of operations. 4 times 5 is 20. 20 plus 3 is 23 over 2. I am fine if you want to leave it as an improper fraction that way. If you want to change it into a mixed number, you can go ahead and do that as well. 11.5. Either one of these will work. That's the first answer. Now we do it a second time with subtracting 4 times 5. So 3 plus 4 square roots of 25 and 3 minus 4 square roots of 25. So then I've got 3 minus 20 is negative 17 over 2. I'm okay if you leave it like that. If you'd rather change it to a mixed number, you could also do that, negative 8.5. Okay, so here are my answers. You're going to get 2 answers. And you might think, Ms. Shopper, you've got 4. Well, actually, I have 2 answers written 2 different ways. All right, again, I'm totally fine with improper fractions. So 5 plus 2 square roots of 4. So we've got 5 plus 2 times 2 divided by 3. That's 9 divided by 3, which is 3. And we're going to go 5 minus 2 square roots of 4, which, whoops, instead of the square root of 4, we're going to do 2 divided by 3. That's going to be 5 minus 4 is 1/3. All right, one more slide, and then we're going to get you working. We're going to be solving the equations with radicals. All right, so again, we've solved equations, same process. The only difference is now we're going to square root our answer. And so in this case, I'm going to take the square root of x. And again, if I write the square root symbol, I do the plus and the minus. All right, looking at number 2, I'm going to subtract 9 from both sides. Again, we're using our equation solving skills. Oops, 41 minus 9 isn't 41, it's 32. I'm going to divide by 2. So x squared is equal to 16. I'm going to square root both sides. I'm writing in the square root symbol, positive, negative 4. Okay. All right. So again, this whole idea of equation solving is very similar to what we've done before. I'm adding the equal sign or the radical sign. So I'm going to do plus or minus 6. All right. Add 4 to both sides. And so I'm going to get that 4x squared is equal to 64. Divide by 4. X squared is 16. When I add the square root symbol, it's going to be plus or minus. All right. Have a great day. See you later.